Welcome to Deep Tips. I'm back with another stream today. So, how are you, everyone? In the previous stream, we did permutation and combination and we focused on permutation. So, today, this streaming will be based on combination problems. So, I request everyone to call their friends who are in grade 11 and want to learn this topic with me. So, are we ready? Yes. So children, what did we do in the previous video? We learned about permutation. So let's recall by the time everyone joins us. So permutation is ordered selection, right? I told you in my previous video that when you are selecting something and order matters, like entering the pin in which you can't change the digits, that is permutation. But when you make a mixed veg salad, you can add cucumbers first, then tomato, then onions, or onions first, then tomatoes, then cucumber. So order doesn't matter. So in today's video, we are going to learn about combination, which is unordered selection, right? So we will understand this with an example so that you can relate it, that where to use combination and where to use permutation. In my previous video, one of my students asked me, ma'am, where do we use it actually and how to distinguish when to use permutation and when combination. Okay, so children, whenever with changing the order, the entire thing change, that is permutation, like entering the digits of your pin or making the words. But when order doesn't matter, like when you're being selected for a cricket team, your coach might say, okay, first is Ram, then Ruhan, and then Sham, or maybe he starts with Sham, Ruhan, Ram, then all three are selected, right? So order doesn't matter whether I take Ram's name first or Ruhan's name first, order doesn't matter here. So let's start with one example. If I'm making a chess club, okay, you all know that in chess two players can play at a time, and I have three members who have joined my chess club. So let's assume the name of those three members is P, Q, R. I'm taking these letters because it's easy to say rather than taking Ramsham. I'm taking P, Q, R. These are the three members who have joined my chess club. So now if they want to play and I have to arrange the matches of these players, what do I need to do? I need to select two members in one team, because in chess only two players can play at a time, right? So what all different combinations we can make? We can make PQ, right? We can make QR also. Q can play with R, and then PR. So do you think there is any other player which is left, or any other combination that is possible? So children, here if I say, okay, P is playing with Q or Q is playing with P, this is one and the same thing, because order doesn't matter whether I'm taking P's name first and Q's later, or Q's name first and P's later. Same way, Q is playing with R or R is playing with Q is one and the same thing. So here I have three people available in my chess club, and I have to make teams based on selecting two at a time, right? So three people are available, so we need combinations of 2 so we can write it as 3C2. And you remember in permutation we wrote 3P2, right? And for combination we are using the letter C. So how many combinations are possible when I have three people choosing two at a time? So we did it like this. So I got the answer 3. 3 combinations are possible. But suppose order matters. Okay, names matter, that the person whose name is written first, if I am writing PQ, so P is the captain or leader. Suppose order matters, that whatever order they are written, it has some importance. Then how many permutations are possible? So in case of PQ, then you will say, okay, P is the captain and PQ are playing. In QR, Q is the captain. So now if my Q is captain, so I need to write QP, right? And if R is captain here, then RQ. and here again RP. So when order matters, I have how many permutations possible? I have 6 permutations which can be chosen. I hope you are clear with the concept that when order doesn't matter, we are selecting randomly and writing the names in any order, that is combination. But here when I added a clause that the letter which I am writing first is leader, so then it became permutation. So did you see that when I am selecting two people like P and Q, so when I am selecting P and Q, they can be arranged in two ways, PQ and QP. So this is linked with the previous video. So when two people are selected, they can be arranged in 2 factorial ways, right? So 2 factorial. So it gives me a clue that if I am finding the permutations, then all the combinations should be multiplied with 2 factorials, right? So here my 3p2 is equals to 2 factorial times 3c2, means whatever combinations I am choosing, if I multiply it with 2 factorial, I get the permutation, right? So can you just pay attention what I have written? Actually, I can generate my general result from here. Now look here, if I divide my 3p2 by 2 factorial, I get 3c2, right? So how do we solve permutations we have done earlier? 3 factorial upon 3 minus 2 factorial into 2 factorial. So this is your 3c2. So it means basically in each selection, okay, it is a combination of 3 different objects taken 2 at a time. So if you have to read 3c2 or anybody asks you what does it mean, it means each combination here specifies that out of 3 people, 2 are selected at a time, right? So now we can solve this. Now if I want to generalize it, let's say NCR. So out of N, I am selecting R at a time, groups of R. So what we do? N factorial upon N minus R factorial into R factorial. So this is my general formula for combinations. So now see what is the difference in permutation formula and combination formula. In permutation, what did we do? N factorial, just a minute, yeah, N factorial upon N minus R factorial. Now I want to stress on this thing that you should be very much clear in your mind that permutation is when order matters. So this was the formula. So if you divide it with R factorial, means whatever you are selecting, there are that many factorial number of ways to arrange that thing. So we are dividing it because we don't want duplicates in combination, right? So if we have written PQ in combination, we don't want QP. If we have written PR, we don't want RP because they mean one and the same in combination, but in permutation they have a different meaning. Okay, that's why we are dividing with R factorial, that if there are 2 people selected, they can be arranged in 2 different ways. That's why I'm dividing it with 2 factorial or 5 factorial, whatever number of people I'm selecting. So that's the reason why R factorial is there in the denominator. Okay, so then NPR equals to N factorial upon N minus R factorial. So far children, we have recalled what we did in the previous video, okay, and now we have started the new topic today, combination. Okay, so yeah, now let's do few more results which are based on this formula. Okay, if I say I have 5 objects and I want to select 5 objects and select 5, right? So in combination, in how many ways you can select 5 objects when you have 5? That means you will select all of them together in one time, right? So that means when N is equals to R, let's substitute when N is equals to R. So N factorial upon N minus N factorial into n factorial, or you can substitute it with r also. Anything is fine because objects and the selection is same. So n factorial upon 0 factorial into n factorial. So this is equals to 1. So there is one and only one way to select 5 objects when 5 are given in total. Okay, so this is case 1. When n equals to r, then ncn is equals to 1. Now when you don't have to select anything, when r is equals to 0. So if I say I have 5 objects, but you don't have to make any group or select anything, that means r equals to 0. So how can you do that? Don't do it. There is only one way, that don't select it, right? So just substitute r. See, the things that look complicated in actually they are much simpler. You just need to think. So here when r equals to 0, like you might be thinking what, but it means you are not selecting anything, so just leave it. There is only one way, that don't select anything. So if you substitute, you will get the answer nc0 equals to 1. This is second result. Okay, now there is one more. So we know NCR means r objects selected out of n objects. So what are the remaining objects? If n are the total number of objects and r are the selected objects, what are the remaining objects? They are n minus r, right? So NC, n minus r are the remaining objects, correct? Now if you use the numbers and try to relate these results, you will actually see the answer for both of them are same. There is a result that NCR is equals to NC n minus r. So that means out of 5, if I am selecting 2 objects and I am rejecting 3 objects, the answer for both, like the combinations for both, will be the same. Why? This y is very important. See here, 5 factorial upon 5 minus 2 is 3 factorial. Now I will be doing directly. I will not be substituting because it is a longer process. But children, in exam, please write the formula and then substitute, especially in your school exams or board exams, because writing the formula and then substituting the values in it carry marks. Some children might be very good in mental calculations, but when you miss writing the formula and substitution and directly start from here, then you definitely lose 1 mark. Okay, so it's important to write the formula and substitution. But those who are writing competitive exams, they can directly calculate and save their time. Okay, so this is the calculation for 5C2. Let's come back to this. Now in 5C3, 5 factorial, what is 5 minus 3? 2 factorial and into 3 factorial. So can you just see, they both give you same calculation. Just here 3 factorial into 2 factorial and here 2 factorial into 3 factorial. Only order is different. So that's why this result holds true for the objects that are selected out of given objects is equals to objects that are rejected. Okay, so these are the results that I wanted to discuss with you and to teach you. These are very important results, and the general formula of combination and permutation is something that you should know properly, that how it is derived and where it is used. Okay children, so today we will be doing 5 to 6 different problems based on combination to have a better understanding of the topic. Okay. Okay, so I am back with my questions. The question is, in how many ways, okay, I'll write the question. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls. Okay, so I want everyone to think about this, that how can we do this. Yes, we'll be doing inverse trigonometry also in future, but children, I want to tell you that from tomorrow onwards I will be focusing on board exams of grade 10, as I have many students in grade 10, so I really want all of you to do well in your exams. So we will be doing chapter wise revision, and when we reach in the month of Jan, we will be doing sample papers in my live stream, so that you can ask me doubts and practice with me. And our chapter wise revision will start from tomorrow, so I'll try to be online at the same time every day, so that we can practice together. Okay, so I hope I have given you enough time to think that how to do this question. In how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? Now here, if you look at this question, first of all, children will think whether permutation or combination, right? So now in this topic, as I have told you initially, that we are doing questions on combination, but I still want you to stress that how to go about it. So when your coach announces a team, suppose it is a team of 3 boys and 3 girls, does it matter if he takes the name of girls first and then boys, or boys first and then girls? It doesn't matter at all. So when order doesn't matter, what do? We find the combinations, right? So if I have 5 boys, I have to select 3 girls, because team is selected together simultaneously, boys and girls. So multiplication rule, 5c3 into 4c3, because I have 4 girls in total, I have to select 3 from them, and from 5 boys I have to select 3 boys. So now children, we can substitute the values. So 5 factorial upon 5 minus 3 is, okay, 5 minus 3 is 2 factorial into 3 factorial. Now this is 4 factorial. 4 minus 3, 1 factorial into 3 factorial. I am directly substituting in the formula, but I am telling you again and again that in your exam you need to write the formula. Okay, so now if we calculate it further, 5 into 4 into 3 factorial upon 2 factorial into 3 factorial, and this is 4 into 3 factorial upon 3 factorial, right? So let's cancel these 3 factorials, and we know 2 factorial is 2 into 1, so I'll just erase this factorial from here and I will change it to 2. So 2 2s are 4. So now 5 into 2 gives you 10, and 10 into 4 is 40. So there are 40 ways to select a team of 3 boys and 3 girls. So this is how we solve this question. Now I'm giving you a simpler question, geometrical based question here. Suppose I have a circle. Okay, this kind of question sometimes come in banking exam or other competitive exams. This is a very simple question. I'll be doing it with a shorter number, but in like examination they generally give bigger numbers, because I want to explain you this. So they say, okay, in a circle, if 5 points are marked, how many chords you can draw? Okay, so now in this type of question, first of all we should know what is a chord. So chord is a line segment that can be drawn in a circle by joining 2 points. So if these points are marked at A, B, C, D and E, okay, and I know this AB can form a chord, then AC forms another chord, here I have AD, and then I have AE. Okay, now I know BC can also form a chord, CD can form a chord, DE, then BE. Like this figure will get complex gradually. So it is really difficult to draw and count all these chords, because in this case I have just taken 5 points. But suppose they say 20 points are marked on the circle, and tell me how many chords can be drawn. Okay, so in that type of question, it's best to use the formula rather than drawing a circle and finding the chords, because that wastes a lot of time. So students, when this type of question comes, it's very clear that it is a combination, because whether I draw a chord from A to B or from B to A, it is one and the same thing. A to C or C to A is the same thing. So order doesn't matter here. I'm using this word again and again. Unordered selection or order doesn't matter for combination. Okay, so here out of my 5 points, I have to select 2, because chord can be drawn by joining 2 points. So 5 factorial upon 5 minus 2 is 3 factorial into 2 factorial. Correct? So if I solve it further, 5 into 4 into 3 factorial upon 3 factorial into 2 factorial. So 3 factorials get cancelled. I know 2 factorial is 2 into 1. So 2 2s are 4. So there are 10 chords that can be drawn when 5 points are marked. Now if I say if 100 points are marked, how many chords can be drawn? It's just a matter of seconds for you to calculate, right? So this is how we solve these kind of questions using combination. Okay, so now my third question is, now I'm giving you a tricky question now, which I have chosen from a competitive exam. Okay, so just think a bit. Out of 7 consonants and 4 vowels, 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be found? So before I start explaining this question, I want everyone to go through this question and read it. Just a minute, not a minute's time. That would be the wrong saying, because in competition, in less than a minute, you need to solve these questions. And so for this, you need to do you need to do your processing little fast. So how to do it faster? Let's try to understand. Out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? So when I'm saying 2 vowels and 3 consonants, I am clear with one thing that is given in my question, that it is a 5-letter word. The word that I'm going to frame is a 5-letter word. Okay, so let's start with the basics that we have to do. That out of 7 I need 3, and out of 4 I need 2, right? So 7C3 into 4C2 will give me the combinations that are possible of 5-letter word. Okay, so this is 7C3. How do we solve this? 7 factorial upon 7 minus 3 is 4 factorial into 3 factorial, then into 4 factorial upon 2 factorial into 2 factorial. So everyone, let's solve this. 7 into 6 into 5 into 4 factorial, because I know 3 factorial is 6, 3 into 2 into 4 factorial, and this is 4 into 3 factorial I'll write, because I know 2 factorial into 2 factorial gives me 4. This 6 get cancelled, this get cancelled. So am I missing something? Okay, 7, 3, 4. 7 into 6 into 5 into 4 factorial. Okay, 7 5s are 35. Yeah, it's correct. 35, and then 3 factorial is 6. So 6 5s are 30, and 6 3s are 18, and 210. So now this is 210 combinations. Now I want you to ask that, is this the final answer? You can type in the chat. Is this the final answer that I am looking for, or if this is the question given in your competitive exam and there is the option 210 also? So shall I stop here, or am I missing something? So I'm waiting for your replies in the chat, as I have many students today. So what do you think? Yes or no? Shall I continue, or shall I stop here if I am in my competitive exam and choose the option 210. Okay, so I'm not getting any reply. Okay, children, so here when you have 210 combinations, so let me break the ice here. Okay, your wish, ma'am. What a wonderful reply I got, that your wish, ma'am, whether I want to do 210 combinations or I want to go ahead. But in competitive, you definitely come down when you take this answer. Okay, I'll come to the point. So children, here I got 210 combinations. That 210 combinations of 5 letter words are possible, but we have to keep in mind that these 5 letters can arrange themselves in how many ways. Like we did in the first video, 5 letter words can be arranged in 5 factorial ways, right? So that 5 factorial is equals to 5 into 4 into 3 into 2 into 1, which is equals to 120. So total words that are possible are 210 into 120. Okay, so this is the final answer, 210 into 120. Now let's try to understand this question, children. They are saying out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed. So they have not asked you that how many combinations of 3 consonants and 2 vowels can be formed. They have asked you how many words can be formed. So here when I just tick 210, then I am writing the answer for 210 combinations. Then I am not saying that these are the number of words, because these 5 letters can arrange themselves in 120 ways. So for each group, because I have 210 combinations, so each group has a possibility of 120 options. So that's why 210 into 120. Now many of you must be thinking that how to do it quickly. So I'll tell you. First, just look at these zeros. So we'll write these zeros, and here I have 21 into 12. This is how I do this mental calculation. Maybe you do in some other way. In 11th, 12th board exams or school exams, we are allowed with calculator, but in competitive exams, you are not. So 21 into 10 gives me 210, and 21 into 2 gives me 42. So this is 252. So I can write here 25200. So this is my answer, that how many words are possible? 25,200 words. Okay, so this was a tricky question which is generally asked in board exams. Okay, so now my next question is a simpler question for you. Okay, so this question is, find the number of ways of selecting 9 balls from 6 red balls, okay, then 5 white balls and 5 blue balls. But this question doesn't end here. They are saying find the number of ways of selecting 9 balls from these given colored balls, and there is a condition that each selection consists of 3 balls of each color. Now please calculate and tell me what answer you get. This is the easiest question. Now we have done the tricky question. Yeah. So Mr. Roosevelt, I have given the answer for the previous question. It is 25,200. Okay, so now I'm expecting my students to solve this third question, where it is find the number of ways of selecting 9 balls from 6 red, 5 white, 5 blue, okay, balls. Each selection consists of 3 balls of each color. So children, this is very simple. Here we know order doesn't matter, whether I put 3 blue first, 3 white, then 3 red, or 3 white, then 3 blue, 3 red, or 3 red. Any number of ways are possible, or 1 red, then 2 white, then 2 blue and then one red, then one white. So see how many combinations I can just speak on about these. So there are many possibilities of selecting 9 balls. So I have given you ample time to think. So anybody calculated the answer for this one? If you have done, please write it in the chat. Now I'm looking at the chat also. Okay, so yeah, from 6 red balls we can select 3, and then from 5 white balls we can select 3, and from 5 blue balls we can select 3. Again I am insisting that because we are selecting all 9 balls together from 3 different combinations, so that's why we are multiplying here. So 6c3, how do we do? 6 factorial upon 6 minus 3 is 3 factorial into 3 factorial, and then 5 factorial upon 3 factorial into 2 factorial, then again 5 factorial upon 3 factorial into 2 factorial, right? So if we calculate this, 6 into 5 into 4 into 3 factorial, and this 3 factorial I can write 3 into 2 because I know this is 6, then 5 into 4 into 3 factorial, then 3 factorial into 2, then 5 into 4 into 3, this is same as the previous one. So yeah, this can get cancelled, this get cancelled, yeah. So 2 2s are 4, 2 2s are 4. So this is 20 into 10 into 10. So I have 2000 ways to select 9 balls from the given colored balls, with the condition that 3 balls of each color are included. And I'm sure if we start counting it, we will definitely miss out many. So that's why combination here, using permutation combination, is the best way to find out the total number of ways. Okay, so I'm back with another question. So this question says, now this is a question based on selection of a committee. As I told in the beginning, as I have already explained in the beginning, that whenever you are selecting a committee, a team where order is not important, use combination. But in this question there is a clause also. Okay, so from a group of, this is my question number 4 I guess, from a group of 7 men and 6 women, 5 persons are to be selected, okay, to form a team or a committee. Okay, so that, now read the condition carefully, so that at least 3 men are there. Okay, then in how many ways we can do that? Okay, so children, now let's read this question. From a group of 7 men and 6 women, 5 persons are to be selected. Okay, so if you look here, just a minute, I'll change the color. So this is the information that is given in the question, that I have 7 men and I have 6 women, but I have to select a team of, or a committee of 5 people, right? And the important clause here is at least 3 men should be there. So whenever we say at least 3 men, that means minimum 3 men should be there, or maximum 5 is also okay. So when I have at least 3 men, so let's start with selection. So out of 7 men I can choose all 5 also, because I'm all okay with that. They have not given anything about selecting women, that one woman or something like that. That condition is not there. Only one condition is there, that at least 3 men, so I am choosing all 5. Or I can also do out of 7 I choose 4 men, and remaining 1 member I choose from women. Okay, so this is 7C4 into 6C1. Or what else I can do? I can select 7C3, means out of 7 men I am selecting 3 men, and 6C2, 2 women I am selecting. Now tell me, can I do 7C2? No, I cannot do, because then my condition does not hold true, because my condition is at least 3 men should be there. So here it ends, because here I am choosing 3 men from 7, so I cannot continue it further. I just need to stop here. Okay, so now we can do the calculation. 7C5, how do we calculate? 7 factorial upon 2 factorial into 5 factorial, plus this you can calculate 7 factorial, 7 minus 4 is 3 factorial into 4 factorial into 6 factorial upon 5 factorial into 1 factorial, then 7 factorial upon 3 factorial into 4 factorial into 6 factorial to 4 factorial. So this is the entire calculation that you need to do. So what we can do, 7 into 6 into 5 factorial. Yeah, I hope you all are calculating with me. So then 7 into 6 into 5 into 4 factorial upon 3 factorial can be written like this, and this is 6 into 5 factorial upon 5 factorial. I know this is a huge calculation, but we need to practice this. Into 4 factorial upon, this is again same, and this is 6 into 5 into 4 factorial upon 2 into 4 factorial. Yeah, it's a big calculation, I know. So 3 into 2, 6 get cancelled, then 4 factorial get cancelled, 5 factorial also get cancelled here. Now here again 3 into 2, 6, 4 factorial, 4 factorial, 4 factorial, and 2 3s are 6. So now let's see. Yeah, here this is there. 7 into 3 is 21. Then I have 5 into 6, 30. 30 into 7 is 210. Then 5 3s are 15. 15 5s are 75. 75 into 7 gives me 525, right? Yeah. So my total is 756. So there are 756 ways in which we can select our committee. Okay, children, so we are left with 2 more different questions. In today's video we will do one question on deck of cards also, because this is something that is mostly asked in exam. Okay, so this question says, determine the number of 5 card combination, okay, out of a deck of 52 card. Out of a deck of 52 card. Again, this question comes with a condition. Okay, they are saying if each selection of 5 cards has exactly 1 king. Now let's read this question carefully, because this card based question is very important. We should be very much clear that how many kings are there. So we know there in a 52 deck of card we divide it in 13 13 13 13 4 sets, right, based on the color and the different symbols on the cards. So there are 4 kings, right? So that means out of those 4 kings I have to select one. That one card is fixed for me. So if you look here, if you draw like this to understand, so here 1 is king. Okay, rest 4 cards can be any other card. So that means 52 minus 4 kings gives me 48. So 48 cards are remaining. So out of 48 cards, I have to select remaining 4 cards. So this 4 plus 1 gives me 5, right? One card I am selecting from 4 kings, and 4 cards, remaining 4 cards I am selecting from 48 cards that I get after subtracting 4 kings from the deck of 52 cards. Okay, so this calculation we can do. 4 factorial upon 3 factorial into 48 factorial upon 44 factorial into 4 factorial. So this you can calculate, right? So if you calculate this further, you get a big answer, and in your exams you are allowed with the calculators. I know in board exams and in 11th 12th especially, so you can calculate it. But if you are in competitive exam, then you need to be very quick with your multiplication, right? So here, where should we stop? That is important. So I am not doing here 4 factorial into 3 factorial, because I know I can cancel my 4 factorial directly, right? So I will stop here at 44 factorial, and here I have 44 factorial into 4 factorial. So this get cancelled, this get cancelled, and I know 3 factorial is 6, and 6 8 gives me 48. So now you can multiply 8 into 47 into 46 into 45. So if I do it on my calculator, I get 778320. So these are the combinations, a huge set of combinations that is possible. Then you select 5 cards, okay, with 1 king and 4 any other cards. Okay, so now I have one more question. So I'm back with my last question, and this is a very interesting question based on school students. So sometimes some students are so good friends that they want to go on excursions together, or they don't go. So this question is something like that. Okay, so in this question there is a class of 25 students. 10 are to be chosen. Okay, to be chosen for a trip, so only lucky 10 will go. Yeah, so 3 students decided either to join together or they will not go. The best friends won. 3 students decided either to join together or none of them will go. Okay, so this is a very important statement here. In how many ways this selection can be done? Okay, in how many ways this selection can be done? So now think carefully that there are 25 students, okay, but out of 25 only 10 will go, and the clause says the 3 students, if they get selected, suppose if teacher selects all 3 by default, then they will go, right? So that means out of 10, if 3 are selected, then out of 10 you subtract 3, then remaining are 7, right? And from 25 also we will subtract 3, then remaining 7 will be subtracted from 22, correct? So what we will do, 22 में से we will select 7. So this is 22 factorial upon 7 factorial into 15 factorial, right children? So if you calculate this, we'll come to the calculation later. This is first case, the condition that those children gave, that if they will go, they will join together or they will not go. So I am assuming that while selecting 10 students, the 3 friends are selected, so they will go automatically, and the remaining 7 will be selected from the 22, because I am subtracting these friends here. Now second case, okay, So second case says, if suppose only one friend is selected, then he will not go, because they have already mentioned that we will go together or we will not go. So now if those three are not going, then what option teacher is left with? Then she has to select remain all 10 from the remaining 22. I hope you are clear with this. This is a very good question from NCERT. Okay, so if 3 are selected, then 7 will be selected from 22. Okay, but if 3 are not going, then teacher has to subtract those 3 initially, and she has to make her selection from the 22 remaining students. Okay, so 22 C10, that means 22 factorial upon 10 factorial into 12 factorial. You will calculate these two. Okay, so you can do these calculations and then add both the selection, because they are asking in how many ways then selections can be made. So basically, if we calculate these two selections combinations and add them, we get the final answer. That I'm leaving up to you. Okay, a little bit of homework for everyone who are watching this video. So children, I am done with today's questions. I hope you understood the concept of combination, and if you are watching my video for the first time, you can watch the stream 1 that is based on permutation, so that you can summarize the whole chapter together, permutation and combination, and you are ready for the exam, because mostly these kind of questions are asked in school exam or competitive exams. Now I am left with one more stream on this topic. In that I will be covering the circular arrangements or some tricky questions based on permutation and combination, and some competitive exam questions also. So that video, streaming I will be doing next week. But the important thing that I want to tell you all, that from tomorrow onwards I will be doing live streaming for grade 10 students, especially those who are writing board exams, and I know they all need practice and to clarify their doubts. So we will learn together. You can share my channel's link with your friends so that they can also connect, and we can build a community who learn together and grow together. So I hope you enjoyed this session. And yes, Dhruv will do differentiation and integration also, but I suggest you focus on grade 10 for now. I want all my students to score 100% marks, and the students who are watching these videos, I really want all of you to grow and excel. And please comment, like, share, subscribe, whatever, for my videos and channels, so that many students can benefit and we can connect with more and more students. So thank you for watching. Thank you so much and good night.